Okay, so this video is related to your coursework, although I know you already had a lecture devoted to the gravity model of international trade. In this video, I would like to discuss where you take the data from, how you specify the data set, how you might formulate the variables, and so on and so forth. So first, for data on bilateral trade, I mean trade flows between two countries, you go to IMF Direction of Trade Statistics. So when you go to this website, it might take you some time. Okay, so you have to choose query. Basically, it will allow you to customize your data set. I mean, choose countries and indicators of interest. And first, let's start with specifying time frame. So probably you're interested in data of annual frequency, because I believe your independent variables like GDP per capita, size of population, and so on will be expressed with annual frequency. So when it comes to the period of observation, obviously more is better, but please keep in mind that time period is likely to affect the result of your estimation as well. So for instance, I will do this for Polish economy, just to show you some example. So Poland joined European Union in 2004. And there are a lot of interesting effects to analyze because of this fact. So you can discuss whether the volume of trade between Poland and European Union member states increased when Poland joined European Union. You can analyze whether there was any adverse effect on the volume of trade between Poland and countries outside the European Union. So probably I should choose the date, start date before 2004. Also, it does not make any sense to choose the date before the collapse of communist regime in Europe, because prior to 1991 there were a lot of other factors affecting the volume of international trade for Poland, and I'm not really willing to specify all of those. So I believe it will be just fine to start with 1991 and till 2019, because probably this will be the latest available observation of annual frequency. Apply. Okay, so now we have time period selected. So when it comes to this menu, here you can choose more than one country. So I would recommend you to specify all the trade partners for countries of your choice in this menu. Again, there is no general rule regarding the number of trade partners to include to your model. So for instance, if I analyze Poland, then it makes sense to include all the European Union member states, obviously. Probably it makes sense to include some major Eastern European economies located close to Poland, like Ukraine, Belarus, Russia, because Russia is still in top 10 trade partners of Poland. If you're not interested in any specific effects, like as I mentioned, I wanted to analyze the effect of joining European Union on the volume of international trade between Poland and European Union member states. So if you do not have this specific aim, then you can just select top 10/20/50 partners. So basically it's up to you. Use your best common sense, and keep in mind that selection of the sample will be also taken into account when grading your paper. So here I will just select several countries, for demonstrative purposes. Apply. Okay, so finally I select counterpart country. So in this menu you can choose only one country. And since I am analyzing Polish international trade, I am choosing Republic of Poland. And indicator. So here you have value of exports and value of imports. Let's choose value of exports. Okay, so please keep in mind that here those countries are treated as the reference countries, So basically, for instance, in this cell, I have export of Algeria to Polish economy in period 1992. However, it will not matter that much. Like, I think you're gonna design some aggregate indicator for the total volume of international trade. So I have no idea why I'm paying that much attention to this. Okay, so then you export. I'm not sure whether you have to. No, previously you had to register on this website. Now it's fine. Okay, ta-da! Here are the data. So we used to have exports. Now you download data on imports. Usually you do not have this value of imports free on board indicator available, so you have no choice. Use imports adjusted for transaction costs. Again, export, Excel file. Hopefully you have it. Okay, so this is something you should get at the very end, when you design your dataset for a regression model. So this is dataset I designed several years ago for education purposes. It's about international trade between Poland and 6 major trade partners between 1995 and 2016. So this dataset is bad. Sample is very biased. It includes only 6 countries, so probably the results of this estimation will not be very impressive, although I do not remember. However, it's fine. It's just fine to show you how it should be designed. So here I have volume of Polish exports to these countries, volume of Polish imports from these countries, and then the total value of international trade. I'm not sure whether I have to emphasize this, but just in case, volume of international trade is not the same as trade balance. If you analyze trade balance of Poland, let's say with Germany, then you have to subtract value of imports from the value of exports. If you analyze total volume of international trade, you sum up. So here I have it. And as you remember, gravity model is a multiplicative model, so it might be extremely challenging to estimate this. So if you take the log form, then it becomes more convenient for estimation. That's why taking log is always a good idea. Also, you're likely to face heteroscedasticity problem, because I swear there will be a lot of unobserved effects you will be unable to incorporate to your model. That's why taking natural log might be a good idea. Okay, so I believe this part is fine. Distance. So in this column you have geographical distance between 2 countries taken from Google Maps. And the problem is that you cannot estimate fixed effects model if at least one of the variables will not change over time. And geographical distance obviously will not change over time. So what I did was designing some variables standing for remoteness. To be honest, I do not remember from which paper I took this specification, but the idea is like this. Not only geographical distance matters, but also the relative importance of the trade partner. So if we discuss bigger economies, they have an advantage in terms of, better infrastructure, better access in comparison to smaller economies. So remoteness variable is designed as the natural log of the product of geographical distance and GDP of the trade partner divided by the world GDP in this period. So again, it kind of captures the relative importance of the trade partner when it comes to global economy, and also it incorporates geographical distance. So now this variable will not be time invariant. No, I think this is something different. So now the value of this variable is not the same for all the periods, and you can easily incorporate this to the fixed effects model. Also, it's kind of possesses better explanatory power, I believe, so at least when I tested this, it provided some better results. Although it's up to you, if your model looks fine and you're lucky enough to have blue estimator immediately, then it's fine. You can also see plenty of other specifications for distance variable in literature. I think there is also distance from the regional center and so on and so forth. So this is up to you. This is just a suggestion. Okay. GDP per capita distance. So this is a common variable to capture the difference in the level of economic development between two countries. And I think it's present in the majority of studies on the gravity model of international trade. So it's calculated like this. So you take GDP per capita in Poland, GDP per capita in the trade partner country, you subtract minimum value from maximum value and take the natural log. As simple as it is. One more thing. In usual specification of the gravity model of international trade, you have GDP, gross GDP, and it might be a good idea, to decompose it to GDP per capita and population. Because gross GDP captures both the size of population and income per capita, obviously, because it's a product of these two variables. So in this case, you have two different effects, because bigger countries usually tend to trade less than smaller countries, probably because of factors endowment. And there is some other explanation as well, but I'm not sure about this at this point. But when it comes to the income, definitely higher level of income implies higher volume of international trade. This is obvious because it affects the volume of imports. Also, GDP per capita distance captures the difference in the level of development between two countries. So according to new trade theory, it should have a negative effect on international trade. According to Ricardian theory, it should have a positive effect on international trade. So what I mean is that decomposing GDP into GDP per capita and population, you're less likely to mess up your model. So, it will just allow you to separate those effects and get a clearer picture about what is going on in your model. So again, scale variable was taken from one of the papers devoted to gravity model of international trade. It's calculated as the natural log of the product of populations of two countries. Finally, we proceed to factors endowment. Okay, so as far as I remember, here I had data about the proportion of physical capital to GDP. Then I just multiplied it by GDP to get the stock of physical capital in Poland and partner country. By the way, everything except in the volume of international trade and geographical distance was taken from the World Bank. This stands for absolute land endowment, like arable land, area of arable land, and the size of the labor force. So then I calculated capital per worker ratio in Poland, capital per worker ratio in partner country, land per worker ratio in Poland, land per worker ratio in partner country. Oh yeah, and this was calculated as the natural log of ratio of those two endowments. So you divide maximum value of capital endowment by the minimum value of capital endowment, depending on who has maximum and who has minimum value, Poland or the trade partner, and you take the natural log of this. Yeah. Okay, maybe I should put this paper on the SOBA. It's in open access and it's really helpful. So here the idea was like this. This variable captures the distance in terms of capital endowment between two countries. So here you have capital per worker ratio for Poland and partner country. Somewhere here, yes, Poland and partner country. You divide maximum value by minimum value, you take the natural log, and the resulting variable indicates the difference between these two countries in terms of capital endowment. Again, if neoclassical theory of international trade is valid, then this variable should have a positive effect on international trade. If it's invalid and instead new trade theory is valid, then it should have a negative effect on international trade. So that's why we like gravity model of international trade that much. You can incorporate any variable in this model. So finally, land endowment was calculated analogously. So for Poland and trade partner, you take the maximum value of land per worker ratio divided by minimum value of land per worker ratio and take the natural log. Ta-da! Okay, so what is missing in this model, because I estimated it using fixed effects, is European Union dummy. So for instance, we can include something like free trade area dummy, so it will indicate if two countries are in the same free trade area or not. So Poland was not a member of European Union before 2004. So for Germany we put 0 till 2004 and then 1 starting from 2005. No, 2004, I'm sorry. However, it's up to you. Actually, it makes sense to specify the next period, I believe. So the same applies to Italy and Netherlands, and Russia never was a part of the European Union, so in fact they never belonged to the same free trade area, and it will be the same for United Kingdom. You know, the only problem is that now for Russia the value of this variable will not change over time. You will have 0 all the time, as well as for the United States, and then I will be unable to estimate my model using fixed effects. And why I emphasize fixed effects model that much is because usually heteroscedasticity is a huge issue in this type of models, because again there are a lot of variables which are not incorporated to this model, although there might be potentially important. There are a lot of factors other than factors specified by economic theory. I don't know, like some political issues or whatsoever. Like, you've got the idea. So usually fixed effects model allows you to cope with the model of heteroscedasticity, which results from this unobserved effects and non-constant variance. So I do not know whether Dr. Beck specified this, but usually he uses more advanced methods of data estimation. That's why, you know, he does not deal with this stuff, but for mortals it might be important. So I take this variables. Yes, no, okay, sorry. Open data user file gravity model. No, sorry, I'm a bit sick and I forgot to copy this column, FTA dummy. Now it's fine. Okay, file, open, user file, gravity model, balanced panel, open, yes, variables. Yes, I want to specify panel interpretation. And I have 6 cross-sectional units analyzed for 22 periods. Okay, finally. Okay, so I will just demonstrate why your model is likely to suffer from all the possible biases if you use OLS. So, as I said here, capital endowment and land endowment are rather stock variables. So it's not a good idea to include stock variables to the same model when you analyze flow variable. So as a result, we have positive autocorrelation, which basically tells you that the volume of trade is positively dependent. That you cannot interpret it in this way. Okay, yeah, it's different. Probably, yes, we have heteroscedasticity problem and so on. So you've got the idea. If you estimate model using OLS estimation, it's not gonna end up well. So I suggest using fixed effects model because, fixed effects model was specifically designed to cope with heteroscedasticity problem. It will not solve all of your problem, but the results will be more reliable anyway. So from this, okay, actually capital endowment and GDP distance have a negative value. The volume of international trade against the neoclassical theory FTA dummy is positive, indicating that okay, actually it was estimated, strange. Okay, whatever. Which indicates that after joining European Union, the volume of international trade between Poland and European Union countries has increased, and so on. Okay, so basically it's up to you. So you can, if you analyze country from European Monetary Union, again, it's a good idea to introduce Monetary Union dummy. The same will apply to FTA, but I already introduced this. I think in this type of model, some kind of cultural proxies are also common, like common language, common religion, and so on and so forth. Post-colonial relationships. For instance, in this case, it will apply to Russia. So using this, again, dummy, indicating whether the country is in the post-colonial relationships with the trade partner. So yeah, as I said, basically it's up to you. Obviously, the more variables you include, the better is the explanatory power of your model. The better the explanatory power of your model is. Okay. I just wonder whether I mentioned everything I wanted to. Yeah, okay. So I believe it's fine at this point, so you've got the idea when it comes to some applied aspects of this estimation. And yeah, thank you for watching.